All right, so this is our Formula Lab 2 resistant forces lab. Just a quick disclaimer before we get into the experiment. Tracker continued to provide data as far as acceleration and velocity that was not on par with the magnitudes expected to be seen in a fallen object study. However, while these magnitudes were off, the numbers still aligned with expected trends and values between the liquids. So due to this allowed us to derive confident conclusions with respect to these tracker issues, and keeping in mind that these may in fact impact our calculations.
In order to run our experiment, we took a rock weighing 0.065 kilograms and dropped it from a height of 4 inches into a container filled with one of 4 liquids. We chose liquids of varying viscosities, which included water, vegetable oil, syrup, and isopropyl alcohol. After recording each drop, we tracked the motion using Tracker, and from that, we developed the graphs that you'll see in a few slides. Using both this and the system schemas, it allowed us to analyze how the viscosity of the various liquids impacted the energy of the rock being dropped through these liquids. So human error is always going to take place in experiments such as this one. Some examples of this could include the height of the ball not being as exact as it could be in between trials. This is just because it's difficult for humans to keep a steady hand. Some ways to mediate this would have been to use a device that drops automatically. However, we didn't have access to this. Tracking also can't be 100% precise. This can be due to blurring of the video, which isn't easy to avoid, as well as some inconsistencies in clicking either too fast or too slow in a given frame. The amount of liquid could also be slightly off in each trial, which could impact how the rock drops through it. By taking our time with the tracking process, we hope to eliminate some of this error that comes with that as well as using the same container for each trial and using the same amount of each liquid. In the system schema we created, we have the liquid having both a viscous and drag force on the rock, and the earth having a gravitational force on the rock as well. We included all of the objects in the system as they all have an effect on the process of the drop directly. In the force body diagram, we see the gravitational force acting in the downward direction and the drag and viscous force having an upward force on the rock as it drops through the liquid.
So the independent variables were the liquid types in our experiment, and so we used water, isopropyl alcohol, vegetable oil, and syrup, and each of them have a corresponding color for the trial. And this is just a tracker screenshot. So for water, our standard deviations for the position was 0.044, for velocity was 0.167, and for acceleration it was 1.13. And so for our velocity, that first dip, we actually didn't include for all of the graphs into the max velocity calculations because it is the first drop before it even touches the liquid. And so yeah, for all of the graphs, we didn't include those. For isopropyl alcohol, our standard deviations for position were 0.042, for velocity was 0.112, for acceleration it was 0.900. For oil, our position standard deviation was 0.038, for velocity it was 0.263, and for acceleration it was 0.789. And lastly, for syrup, our standard deviations were for position were 0.030, for velocity 0.047, for acceleration 0.392.
So in order to figure out how this drop affected the max velocity and the liquids played a part, we ran a series of calculations using the coefficient calculation as well as the force of viscous and force of drag in order to determine the factors within the study. First, we calculated the viscosity coefficient by using variables such as the mass, radius, density, as well as the force and height of the rock in order to determine what the coefficients were. To keep consistency throughout the trial, since the rock was dropped from the same height for each trial, we took the velocities and acceleration when the rock was 0.058 meters from the ground in each trial. This allowed us to determine the coefficients for each of the 4 liquids. The first being water, which had a coefficient of 36.1 kilograms per meter times second. Alcohol had 47.6, oil 59.6, and syrup had the highest at 94.5. Now, in relation to the forces, we see that the water had the greatest force, viscosity and drag, force of viscosity being 1.64 newtons times second per meter squared, where syrup had the lowest at 0.68 newtons times seconds per meter squared. Now looking at their max velocity, we see that water had the greatest max velocity at negative 0.380 meters per second. Alcohol had the second highest at negative 0.25 meters per second. Oil, negative 1.60 meters per second. And syrup had the lowest at negative 0.060 meters per second. These were negative because our point of reference was the ground, and dropping towards the ground was considered the negative direction in our study. Now, here we see the calculations being plugged into the respective equations for all four liquids. We see the first would be coefficient, second is the viscous force, and the third is the drag force. And it's shown and displayed on these four different slides or sections. So now what do these calculations mean in conclusion for our study? Now with regard to the viscosity coefficient, the coefficient was greater in liquids that appeared thicker in texture as opposed to water. These liquids, which would be common knowledge, would be syrup, which appears thicker, meaning that it is more viscous. Due to the fact that it is more viscous, syrup also experienced lesser velocities and accelerations, and in turn forces due to the fact that it is moving slower. Therefore, the impact of force that's felt through the rock in syrup is much less than water, which was seen in the calculation for force of viscosity and drag. Water had the greatest force but the lowest coefficient, where syrup had the greatest coefficient but the lowest force. Now, to answer our research question, how does viscosity of a liquid affect maximum velocity? As viscous coefficient increased fluid to fluid, the maximum velocity seen by the rock decreased. And this was shown evident as syrup had the lowest velocity but the greatest viscosity, and water had the greatest velocity and the lowest viscosity, than isopropyl alcohol and oil. And these all lined up with their coefficients accordingly. And that concludes our formal lab.